Hello. Now, today we're going to look at pensions. So we're dealing with installments, so we have multiple payouts in this case. So a pension is where you are going to get a sum of money, the same sum of money, every week or every month or every year for a particular period of time in the future. So to find the value of a pension, we find the present value of all of those future payments, and that's the value of that pension plan. A note that is very important for pensions and generally finding the present value of our future payments is that we assume that those payments are made at the end of each period. So if I have a pension plan, the first sum of money I'm going to get, if it's say a yearly plan, the first time I'm going to get money is a year from when my pension starts. That's the assumption, that we are getting our payments at the end of each period. This is in contrast to our savings or our future value problems that we already looked at. So present value problems, we are paying at the end of each period, assumed to, and future value problems at the beginning of each period. They can tell you explicitly to do differently, but it's assumed that you would be paying at the end of each period for present value or pension type problems. Now, I want €1,000 every 3 months for 5 years. If the quarterly interest rate is 5%, what is the value of this plan? So I recognize that I'm looking for the present value of future payments, so I'm going to be dealing with my formula here. And just a point, you will often see capital A instead of capital F for the future payments. This is to try and avoid confusion with F in different contexts. So capital A can often be seen instead of capital F, and that will particularly come up in the mortgage questions we'll do later. So what we're going to do is write out our formula. Our present value of our plan is the sum of all of these future values. Is the sum of all of our future values. That's what we said in English here. And this is our formula that we know from page 30 in the log tables. And yeah, we recognize we have a bunch of payments going to happen, and we're paying the same amount in each time. So we're going to end up with a geometric series. It's just going to have more fractions in it this time because we're dividing by this business here. So we have got our formula written down. So let's write down all of our different bits and pieces. So from the English of this question, each one of our payments, our F's or our A's, depending on which letter you go for, is going to be €1,000. And our quarterly interest rate, I'm going to go IQ just to give it a label, is going to be 5%, which is our 5/100 that we always write in explicitly. And we want our payments every 3 months. So what does that work out to? Well, if our payments are supposed to happen every 3 months, 3 months in terms of our years would be a quarter of a year. So we'd have a payment every 3 months or every quarter. So our interest rate and our periods of payment are the same in this question. So our time is going to be 5 years, and there are going to be 5/4 quarter years in that. So we want to get paid every 3 months. That's a quarter of a year. So there's going to be 4 quarters in every year. So we are dealing with 20 quarter year time periods. So let's draw out our picture now that we have our different bits and pieces. I don't think I'll put that there. So I have my 20 periods drawn out. Again, for a long list, we can just do a ... in between instead of having to draw out 20 lines. Now, I want to know the present value. So I want to get all of my future payments to this point. So what happens with my payment that I'm going to get last at the end of this 20th period? Well, to bring it all the way up to the present, this time my arrows are going the other way, to bring this payment all the way up to the present, it's going to be my €1,000 divided by 1 plus 0.05 to the power of 20. I'm bringing it back from 20 months, 20 quarters prior. This one is going to be in for 19. And to bring this, the first payment that I get is going to be €1,000, and it only needs to be brought up to date by 1 year. So again, I end up with a geometric pattern. I'm going down. So my present value is going to be the sum of all of these things. So it's going to be 1,000. I'll write that out. So when I write out all of the sum of all of these payments, I'm going to recognize I have a geometric series again. So I'm going to write down my geometric series formula. P is going to be either sum of all of these things is A on 1 minus OR to the N all over 1 minus OR. And we're looking at page 22 in our log tables for this formula. And let's write down what all of our different pieces are. If A is 1,000 all over, come back to you in a moment. So we sub our different values in here. We have our formula. We write down all of our different terms from our series that we have explicitly written out. Do not try and skip any of these steps. It's almost guaranteed to lead to an error. So we write down and we sub everything in carefully in brackets. Be very fond of brackets with these types of questions. And when we sub all of that into our calculator, in this case there's no rearrangement needed, we end up with 12,400, 2.21. So that's the present value of this plan, where we're getting €1,000 every quarter for 5 years. That's what the present value of that plan is, assuming a quarterly interest rate of 5%. Now, another question: how much must I save in total? So when I retire in 25 years, I get €1,200 at the start of each month for 20 years at a monthly interest rate of 10%. There's a lot going on here, but the big thing that we need to capture is we have 2 periods of time going on here. We're told about 25 years time is when I'm going to retire, and I want to get these payments from my pension for 20 years. So I need to know the value of this pension. That's effectively what I'm being asked. I want to know how much I need to save so that on the day I retire, I have this pension. So I need to know the value of that pension. But when do I need to know the value of the pension? Is it 45 years from now, or is it 25 years or 20 years? What's going on? Well, I want to know the amount of money I need the value of the pension when I retire. So that means that the present time for calculating the value of the pension is the day I retire. This is the key thing to recognize in a question like this, where they're playing around with time periods. I need to know the value of the pension, which means the value of all of the future payments, and I get that at the beginning of the pension. So it's at the day I retire is my present time. So that's what I'm going to write in, and then we'll start into the question. The other thing to recognize here is that I have a special piece of information. I'm told I am getting paid at the start of each month, and this changes things. We know that we would normally assume that we were getting payments at the end of each time period. This time we're going to get paid at the start. So what effect is that going to have? Well, let's write down our formula anyway. We're looking for the present value of something, so we're going to be using our formula here. Our sum of our future values. some of our present values, I should say, present values of future payments. So let's write down our different pieces. We have F would be our €1,200. Our I is in months and is 10%. It's 10 out of 100, which is 0.1. And our time is in years and is 20 years. I'm interested in monthly payments, so I need to convert this into months. I wouldn't bother converting this into years because I want to know about monthly payments. So that's going to be 20 years by 12 months in each year is 240 months. So I now have everything in my units that I want. So let's draw a picture. Now we have our diagram where our marker drawn in. So what happens on the day I get my pension? I actually get €1,200. I get that at the beginning of the first period, which is immediately when I retire. On the day of my retirement, on the day the pension starts, I get that amount of money. So that is the present value. That is its present value. It is at the time that I'm considering present. Then my second payment comes at the beginning of the first year, and my last payment becomes at the beginning of the last period, which would be 239 months in. But importantly, and it's very important we get this idea clear, this is the 240th payment. I got a payment after 0 amount of time, and my 240th payment is at the beginning of the 240th month, but that is only going to give 239 months of kind of reverse interest to bring it back up to the present. So this is our effect. So let's write down that as a series. Now if we write out all of these pieces from our diagram, again remembering that we have 240 terms in this list, we are going to end up with 1,200 plus all of our present values brought up to date. We recognize we have a geometric series, and we write that formula down from page 22 in our log tables. We write down all of our terms that we're going to sub in, and then we sub them into our formula. When we're subbing into our formula, onto our calculator, I should say, again, be very careful that everything possible has brackets around it. You can put brackets around that as well if you like, but critically we have to be careful of this power going on this bracket in here, that we aren't putting it on the main bracket there. And when we do that, we get out the present value of this plan. So again, present value of all of our future payments, the day we retire is going to be the present value we're looking for. That's the amount of money we would have needed to have saved to have as a block of money in order to be able to pay for this pension that we want on the day that we retire. And we can see the effect of the fact that we're told that our payments are made at the start of each period when we draw that